Okay, water. Now this is going to freak you out. Don't panic. Water can act as both an acid and a base. Take a deep breath. It's fine. It's going to be fine. Substances are called amphoteric. It can be both a base and an acid. It's fine. It's H2O. It can do anything. It's crazy. So you have a strong base, or you have a base like ammonia. You have water. Water's going to act as the acid. You have water here acting as the base, and HCl is the acid. It can go either way. It's fine. Don't panic. It's not a big deal. When in contact with a base, water donates a proton. When in contact with an acid, water accepts a proton. It's not really that big of a deal. It's H2O. It's got two hydrogens. It's fine. The ion product constant for water. Now this is going to cause you to have a sympathetic nervous response. It's going to cause you to don't panic. I want you to know this information, but we're most likely not going to play with it a ton or use it, so just relax. The ion product constant for water is the hydrogen concentration times the OH concentration. So we want to know the hydrogen ion concentration times the OH concentration, the acid times the base. So don't panic about this. We're just trying to play with these numbers, the -14, and go back to some concept where we can tell if it's a strong acid or base. Solutions are identified as acid, neutral, or basic, according to the values of their hydronium ion, which is basically H+, and their OH concentrations. An acid solution is anything smaller than -7. A basic solution is anything greater than -7. So this is very similar to Arrhenius's. If it's an 8, it's basic. If it's a 2, it's acidic. If it's exactly equal to 7, it's neutral. It's very similar, so don't panic. The pH of an aqueous solution is a number, usually between 0 and 14, that indicates the hydrogen ion concentration of a solution. So pH is the negative log of the hydrogen ion concentration. So you're going to have to use the log button on your calculator. Don't panic. I'll show you how. Relax. Again, pH smaller than 7 is acidic, larger is basic, and exactly is neutral. The pH scale covers an enormous range. These things are logarithmic. So one move from 2 to 3 is a logarithmic scale. It's huge. It's actually a 10-fold difference. So 1 going from 2 to 3 is actually a 10-fold difference. You're like, well, it shouldn't be that big of a deal. It is that big of a deal to go from, and you'll see that when we get to blood. It's a big deal to move your pH of your blood. Death. Calculations, the whole thing can really be simplified if you look at your pH, your hydrogen ion concentration, H3O or H+, depending on how it gives it to you, plus the OH concentration equals 14. So if I give you this and it's 7, dude, this has to be 7. If this is 2, this has to be 12. Conversely, if this is 7, this has to be 7. If this is 2, this has to be 12. Do you see what I'm doing there? Has to equal 14. Okay, so it's not really that big of a deal. It's not calculus. Settle down. You do have to use the log button on your calculator, though. I'm sorry. Okay, milk has a hydrogen ion concentration, right, of 4.5 times 10 to the -7. What is the value, the OH value? Ooh, so we're going to have to put those two things together and see what the OH value is. Of milk, is it acidic, neutral, or basic? Okay, the OH concentration can be found by dividing it by this. So the Kw is the hydrogen ion concentration. So we know that it's 1.0 times 10 to the -14. That's just the standard. And this number here is 4.5 times 10 to the -7. It's just Kw, which is a standard, over the concentration they gave you, which is this, which gives you 2.2 times 10 to the -8. Again, you have to use these fancy buttons on your calculator to get this. Now, milk is slightly acidic because it is larger than 1.1 times 10 to the -7. It's 2.2 times 10 to the -8, so it's acidic. Does that make sense? Let's move on. Let's do another one. The hydrogen ion concentration in coffee is about 1 times 10 to the -5. What's the pH? Boom. It's 5. Because it gave you hydrogen ion concentration, and you can just say it's 5. The pH of coffee is 5. Slightly acidic. Let's do another one. Lemon juice has a pH of about 2. What is the hydrogen ion concentration? 1 times 10 to the negative 2. See, you're panicking. There's no reason to panic. A cleaning solution is found to have, oh, you got OH. Anytime you have OH, you're like, man, I'm going to have to subtract because it should be in hydrogen ion concentration. And in this case, it's in OH. So this concentration is 1 times 10 to the negative 3. What are you going to do? You can set up this whole equation here, and it'll give you the same. It'll give you 11, or you can just subtract 14 from 3. You know the pH of this is 3. You know the pH has to equal 14, so this has to be 11. So you can do it either way. We will do these problems in lab. Do not panic. It's really just subtracting from 14. Okay, again, you're finding the logarithm. This is done. We're going to talk about calculator usage because this is a super easy equation, but what happens is people don't know how to use the inverse button. They don't know how to use the log button. Everyone panics. Just settle down. We'll talk about it in lab. We'll all go through and use our calculators. Okay, the simplest but least accurate method of pH determination is acid-base indicators. These little guys change color. So this is what we're going to do urine analysis with. You're going to dip it in there and it's going to tell you what the pH of your pee is. The pH of your blood, it's very important. These things are super vital, and it's basically a color change. You can do it in liquid. You can do it with these little tabs, and it'll change color and tell you what the pH is. Super fun. Maintaining the pH of blood and other fluids within narrow limits is accomplished through these super fun things called buffers. If you didn't have buffers in your body, you'd probably be dead. Buffers are mixtures of weak acids and their conjugate bases, and they accept and donate hydrogens to keep the pH constant. Maintaining the pH of blood and other fluids within narrow limits is accomplished using buffers. See, your pH of your blood needs to be between 7.34 and 7.45. Otherwise, bad, worse, bad, worse. You don't want that. The Henderson-Hasselbalch equation. Don't worry. Basically, it's just giving you this equation. It's just telling you how it works. When the HA is a weak acid and the A is the conjugate base, you get a number. Don't panic. We're not going to use it. I just want you to know that it exists. So settle down. Okay, acid base. So these are all the buffers in your body. There's buffer systems that absorb and move things in your kidneys, in your stomach, all kinds of really interesting things. We may talk about pH distribution in lab. Each of the fluids in our bodies has a pH range suited to its function. Blood plasma is between 7.34 and 7.45. But look at these changes. Your saliva is 6.5 to 7.5. Your stomach is between 4 and 6.5. The upper stomach, the lower stomach is 1.5 to 4.0. That is a pretty low pH. So let's say you're going from 1.5, your duodenum, this little piece that comes and hooks up between your small intestines and your large intestines, that puppy is right at 7. So you're going from 1 to 7. It like shoots it in there, and your duodenum sort of converts it back to a normal pH. So it doesn't, acidify the rest of your body. Your small intestines are between 4 and 7. Your large intestines are between 4 and 7. And that's the process by which it goes through your digestive system. Again, more pHs in the human body, and here's the pH of your blood between 7.35 and 7.45. More buffs in the body. The reaction and equilibrium that take place throughout the body are very sensitive to pH variations. Maintaining the pH of blood serum is accomplished by the carbonic acid bicarbonate buffer system. This thing is key to keeping you alive. Buffers. The bicarbonate buffer system is intimately related to the elimination of CO2. Breathing out. You got to get that stuff out. You got to get the CO2 from your big toe out your mouth without causing all kinds of pH chaos all throughout your body. So enter bicarbonate buffer system. Okay, I'm going to talk about alkalosis in one more video. Okay.